My name is Michael Erb. I'm a postdoctoral researcher at the University of Texas Institute for Geophysics. I use climate models to study how the Earth's climate has responded to different forcings in the past. So currently I'm using a computer model to look at how three different forcings have affected the Earth's climate in the past. One is CO2, which everybody's interested in now because we're studying how it might affect future climate. But there are also other forcings relevant to past climate, such as ice sheets. As they grow and get larger, they're going to reflect more incoming solar radiation away from the Earth and cool things down. That also affects sea level, because when you freeze more of the Earth's water as ice sheets, you lower the sea level, you expose more land. That affects climate and circulation patterns. There are also changes in the Earth's orbit, changes in the shape of the Earth's orbit and the tilt of Earth, and also when exactly the planet is closest to the Sun. So all those things are changing over thousands and tens of thousands of years, and together they all influence the Earth's past climate. And I'm looking at trying to better disentangle how those forcings have affected climate in the past, with the aim of better understanding how the climate system works. Pretty much, yeah. It's not technically required. You don't technically need a postdoc. But academic positions and research positions are very competitive. And you pretty much need a postdoc to be competitive. Honestly, nowadays it's becoming more common to need more than one postdoc. But yeah, I think that's pretty much the case in most of Earth science. This is my first postdoc. I've been here, this is my second year. And I have about 9 more months on it. Mostly the people. So I was doing my graduate school at Rutgers University in New Jersey. I got my PhD there. So currently I work with Dr. Charles Jackson. And during my PhD work I had emailed with him a little bit. There was a project we wanted to work on a couple of years ago. But it turned out, in the end, we wanted a couple more climate simulations done first. So I didn't do it during my PhD, but it turned out to be a great postdoctoral project. And I got to meet him at one of our big annual meetings. Got to meet him in person a couple of years ago, and we got to talking, and it's a project he really wants to do too, so everything kind of worked out from there. So in my postdoc, I wanted to be a little bit more independent, take kind of a more leadership position in my research. Because during dissertation work, you should become very competent at what you're doing, but at the end of the day, you're still a student. In my postdoc, I wanted to become a bit more independent, take charge of my research, and also to make more connections. Postdoc, generally you go to a new place, you work with a new group of people. At meetings you meet all sorts of new colleagues, and just growing that circle of colleagues and peers and researchers helps you make more collaborations in the future. Kind of builds your network and makes you a better researcher. Well, one great thing about the Institute of Geophysics here at University of Texas is that there's a broad variety of research going on. There's people doing work on earthquakes and on moons elsewhere in the solar system, and on different geologic processes. More relevant to me, there's people working on climate records that come from cave formations and from ocean sediment and from ice cores. And having all of this different but related research going on helps you make connections, helps you think about something in ways you maybe wouldn't have otherwise. So you get talking to people and you realize all these connections exist, and you think of new avenues for your research to take, which has been great. Yeah, so I definitely love to go into academia. I want to be a college professor and kind of balance teaching with research. Go to some big research university, or even a smaller, more teaching-oriented college, because there are a lot of very interesting things in earth science and atmospheric science in particular, since that's more my field of study. And so I both want to delve into those topics with research and also share interesting things from those fields with students. So I wrote a book called Kelvin MacLeod and the Seaside Storm. And basically, in my professional career, I want to be a college professor. You know, I want to teach kids once they get to college. But really, by the time people get to college, they've kind of decided whether they're interested in science or not. So I also wanted to reach out to younger kids as well, to show them how interesting the world was and how useful the scientific method was. So I tried to combine really interesting things in atmospheric science and science in general with an exciting fictional narrative. So in the book, one of the main characters, he's named Kelvin MacLeod, and he's a weather detective. It means he investigates and he solves crimes using his knowledge of weather and science. So him and his nephew, they get this mysterious letter and end up going to this small New Jersey town on the coast, where a man died in a hailstorm. But as they start to investigate, it starts looking more like murder. And then as you go through the book, there's a lot of real science woven into it. You know, why is the sky blue? Why do we have seasons? And really, what causes the weather at all? And one really fun thing about the project is I've gotten a chance to talk with actual middle schoolers. And the teacher will read it with the students. And then afterwards, they'll contact me and we'll do a Skype talk, where all the kids get to talk with me and get to ask me questions. And I can ask them questions like how the weather has affected their lives, and whether they've seen hail themselves, or maybe they were affected by a tornado. And it's a lot of fun to talk to the students and really try to get them excited about weather and science. Because I think middle school, and elementary school too, are ages where you can develop a love of something and carry it with you through your whole life. Actually, myself, I've always loved science and math in general. It wasn't until college when I decided I wanted to pursue atmospheric science. Because I kind of had a broad love of science, and I decided to take, a variety of different introductory classes, like chemistry and physics and math and engineering. But what I found I liked the most was atmospheric science, because it's just so relevant to people's lives. Weather is something you have to deal with every day. Maybe just in small ways, whether you wear, shorts or long pants. And maybe sometimes in large ways. Like one time when I was in New Jersey, Hurricane Sandy came through, and Hurricane Irene the year before, and really affected people's lives. Some people in huge ways. But weather and climate in general is just very immediate to people. So I like that. I like researching something that really affects people. But like I said before, I really like the diversity of research being done here. And also, just really high quality research happens here. So it's a great experience. The primary goal of being a postdoctoral research is to improve your research and to form a bigger network of colleagues and peers. And I definitely think there's a lot of that here. I would definitely like to become a college professor. So in the coming year I will be applying for those sort of tenure track positions at big research universities. But I'll also be applying for different positions, like other postdocs, or maybe teaching positions at smaller universities. I have about 9 months left on my postdoc here, so I have a little bit of time to put some lines in the water, to try some different options and see what happens. So it's an exciting time.